Ever caught a snowflake on your tongue and wondered about the science hidden in that fleeting masterpiece? On Unbelievably Science, we're about to lift the frosty veil on one of nature's coldest mysteries, the chemistry of snowflakes revolution. From bizarre laboratory experiments with supercooled water to molecules dancing through Arctic clouds, get ready for a chilling adventure where ordinary H2O becomes an architect of microscopic marvels, no two patterns quite the same, all shaped by invisible forces. It's not just winter weather, it's chemical artistry in freefall. The story of snowflakes begins not with winter winds, but with the chaos of molecular collisions in the upper atmosphere, where water vapor shivers at the edge of existence, seeking to crystallize into something spectacular. Consider this: every snowflake is born from a speck, dust, pollen, even a bacterium. These humble nuclei act as the silent architects upon which the first ice molecules cling, catalyzing a revolution at microscopic scales. In 1936, a little-known Japanese physicist named Ukichiro Nakaya embarked on an audacious quest to create artificial snowflakes in his laboratory. With microscopes and frigid patience, he became the world's first snowflake engineer, uncovering that artistry and structure emerge from temperature and humidity alone. Unseen by human eyes, the formation of a snowflake is a battleground, a place where hydrogen bonds lock into place and then break apart, only to reorganize into six-fold symmetry that echoes through millions of years of planetary chemistry. What's truly astonishing is this: the shape of every flake is dictated by infinitesimal changes in atmospheric conditions as it falls, colder in one layer, more humid in another, meaning that no two flakes follow exactly the same chemical choreography. As the flake journeys downward, experiments have shown it can transform from simple hexagonal plates to elaborate dendritic stars in mere seconds. It's not just beauty, it's adaptive chemistry in action, responding to fluctuations with mesmerizing speed. In recent years, scientists have discovered that pollution, microscopic particles from wildfires or exhaust, can invade this delicate process. Some forms of soot change how water molecules attach, creating thicker, more chaotic flakes that fall faster to Earth. Let us pause to imagine this. Deep within Antarctic ice cores lie snowflakes older than humanity itself. Preserved for hundreds of thousands of years, their crystalline secrets give up evidence, not just of ancient atmospheres, but of volcanic eruptions halfway across the globe. The chemistry shifts again as each snowflake lands and begins to metamorphose. Surface molecules rearrange in response to wind and sunlight, a phenomenon called sintering, which helps bind loose powder into solid ice or glistening crusts atop mountain slopes. Beneath the lens of electron microscopes, we see that a snowflake's surface is never smooth. Instead, it bristles with nanoscopic spikes and ridges, maximizing how much sunlight it scatters back into space, subtly influencing climate on a planetary scale. Now consider supercooled water droplets, an enigmatic phase where liquid persists at temperatures far below freezing. Only upon contact with a nucleus do these droplets snap into crystalline order, releasing latent heat that ripples outward through surrounding air. For decades, it was believed all snowflakes were pure water, but recent studies using mass spectrometry have unveiled traces of formaldehyde and nitrates, frozen chemical fingerprints left by forest fires or lightning storms carried on high-altitude winds. In laboratories today, chemists explore how designer molecules might guide ice formation for practical miracles, clearer ice for optics, or novel surfaces that inhibit icing on aircraft wings. This is nature's chemistry hijacked for human ingenuity. In an unexpected twist, astronomers studying distant comets found that icy grains forming in deep space share almost identical molecular arrangements to Earth's snowflakes, a symmetry transcending planets and epochs alike. Every blizzard writes its own chemical epilogue. When spring comes and the thaw begins, melting snow releases locked-away compounds, nutrients and pollutants alike, triggering blooms in streams and lakes that ripple through entire ecosystems. If you loved these mind-blowing facts, hit like and subscribe so you never miss an unbelievably science surprise.